So now let's talk about proteins. This is the third macromolecule. Proteins are composed of carbon, hydrogen, oxygen, nitrogen, and sulfur, chones. And this is actually going to become very, very important later on when we are talking about Avery and McLeod's experiment, okay? But at the moment, I just want you guys to understand that proteins are made up of chones. Now, its monomer has a very, very special name, and it is called amino acid. And unfortunately, this is one molecule whose molecular structure we have to memorize. Okay, so it's made out of NCC, nitrogen, carbon, carbon. And I like to memorize it as North Carolina College. Don't ever flip them, because if you flip it, it doesn't make sense. It becomes College Carolina North, and no such thing exists. Anyways, North Carolina College is composed of, on the N side, with 2 hydrogens, on the central carbon, hydrogen, and then a carboxyl end. Now understand that we have 20 different types of R groups, aka 20 different types of amino acids, okay? And remember, the N side, we call this the N-terminal, right? Or the amine end, okay? And then here, the C side, we call the C-terminal, or the carboxyl end. And it is on the carboxyl end that we are going to keep attaching new amino acids, okay? Which takes us to the next topic, the polypeptide. Oh, the polymer, I should say. The polymer. Okay, so we have 2 names for the polymers. We have polypeptide and protein. Now, the difference between a polypeptide and a protein is how many amino acids we have. If you have more than 20, usually it's going to be classified as protein. If you have less than that, it's going to be classified as polypeptide. So, it's basically NCC, 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 and so on and so forth, right? Now, remember, we have hydrogen, right, with OH, hydrogen with OH. I want you guys to kind of see this here. So we have R group 1, R group 2, R group 3. Oh, look, this is what's happening. I want you guys to see this. The hydroxyl group from the carboxyl end and the hydrogen from the amine end are going to get together, and they're going to leave as HO. HOs like to leave, right? So when they leave, we end up creating a bond between carbon and nitrogen. Do you see that? This is the bond that I've created right there. This special bond has a special name. It is called a peptide bond. It is a covalent bond, hence we have changed the chemistry of the amino acid. It is now a polypeptide or a protein. It is no longer just an amino acid. Good? All right. Now, the important thing about protein molecules is that you have to create a very long chain of protein molecules and fold it the right way, because proteins are very, very, very specific. So what becomes very important is its structure, okay, the way that it's folded, and the type of bond that it had used to create the particular structure. We happen to have 4 different structures that we can identify. We call them primary, secondary, tertiary, and quaternary. So the primary structure is basically amino acid, bonded to amino acid, bonded to amino acid, bonded to amino acid, bonded to amino acid, and you get the idea. We have peptide bonds holding amino acids together, creating a linear structure. Good, good? Good, good. Now in the secondary structure, it kind of looks like this. Okay, so basically all it is this. It's amino acid twirled, okay, to create a chain. Or, remember when we were little and we used to kind of fold paper to make a hand fan, you know, like the fan, like origami type. So I used to do that. I don't know if you have, but it's kind of like an accordion if you look. And to keep these all completely folded, we have a special bond, and these special bonds are called hydrogen bond. Remember, hydrogen bonds are not real bonds. These are attraction forces, but at the end of the day, we still call them bonds in the secondary structure of a protein folding. So just remember that hydrogen bonds are associated with secondary structure, and this spiral-looking thing is called the alpha helix, whereas this accordion-looking thing is called the beta pleated sheets. So these are all buzzwords. If you see the word alpha helix, hydrogen bond, beta pleated sheets, hydrogen bonds. Got it? All right, so now let's continue to tertiary structure. Tertiary structure is basically alpha, 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 beta, 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 alpha, 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 beta, 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 alpha, alpha, alpha. Do you see that? It's a combination of alpha and beta pleated sheets. Oh, look, guys, we just created a globule. Okay, so this is going to be held together with disulfide bridges. So I know that this is just a covalent bond, but this covalent bond has a very special name, and this is called the disulfide bridge. Okay, and this is very special because sulfur only exists in protein among all other 4 macromolecules. Good? All right, so now let's continue. Let's talk about quaternary structure. Quaternary structure is when you have 3 or 4 more of these globules put together, held by, I don't know, sometimes an inorganic molecule such as iron. And in this scenario, I kind of created a hemoglobin molecule. If you guys remember, hemoglobin is a protein molecule that exists in your red blood cell that carries oxygen. So it's a cushion for oxygen. Good? All right, so let me teach you how I kind of remember these. Okay, think of it as this. I kind of remember this as the linear structure is like fabric. Oh, sorry, not fabric. As thread, okay? So it's just a linear long chain. You put lots of thread together, you end up with fabric, right? You cut and paste fabric, you end up with a t-shirt, right? Oh, look, guys, t-shirt is wearable. You can wear it outside. So starting the tertiary structure, this becomes functional. Okay, so you can actually stop here, or you can get really, really fancy and create an outfit. Good?